local 911 calls.
How about that? That's amazing. All right, thank you for breaking that down for us, Alec. Let's now send it back to the room there at Hangar AE and check in with Mick and Megan.
Hey, thank you guys so much. Yes, we are expecting to begin tanking this rocket in about 38 seconds from now. We're targeting T-minus 50 minutes for the beginning of propellant load of the Falcon Heavy rocket.
Yeah, we'll start flowing RP-1 into the first stage, getting some rocket propellant number 1 or high-grade kerosene on board of all 3 boosters at the exact same time, filling them pretty quickly, and then we'll hear a call out later for LOX load, where we start putting liquid oxygen into the first stage boosters also. So this will be a moment where we have set our T0 for 5:26 p.m. tonight. This will confirm that for us.
The launch auto sequence has started.
And there we go. We heard them start the auto sequence for loading, it sounds like. So we should start RP1 into the 3 booster tanks. And we are seeing the telemetry on the rocket with the valves starting to fuel the 3 first core boosters. So things are looking good for us here, Megan, and the team is continuing to proceed forward with the count and working no other issues at this time.
That's fantastic news. And for those who are going to listen along for the rest of the broadcast, we are going to be hearing them fueling and giving updates on fueling of those 3 first stage boosters that we see there on the screen. PY and NY refer to the side boosters, and then CC is the center core. But as Mick said, those will be fueled all simultaneously, currently happening with RP1, which is rocket grade kerosene. So the next fuel that they'll propellant that they'll start fueling the rocket with is going to be liquid oxygen, and that is a super cold propellant that they're working with.
Yeah, absolutely. That densified LOX that SpaceX uses, they densify that down to super chilled minus 423 so that they can get as much liquid oxygen into the tank as possible. And that's a reason we now have picked our T0, because once we get it that cold and we start loading the vehicle with it, we can't recycle that into the window. So because of the boil off and the way liquid oxygen performs. So moving that forward, we're doing well. And you mentioned the PY and the NY. For us, for those listening, that's the negative Y and the positive Y that we refer to the side boosters on, due to the orientation that the vehicle is on the pad, that the team can analyze trajectory for the rocket when it lifts off, knowing what's going to happen to those side boosters later on tonight.
So here we go, guys. We are beginning to fuel the Falcon Heavy rocket with rocket-grade kerosene, like we said, coming up at T-minus 45 minutes. That's when we'll start loading the super cold liquid oxygen. Super cold, I mean negative 341 degrees Fahrenheit. So a very delicate operation, one that is, as Mick has been saying, monitored by the team very closely. And because of those super cold temperatures, we have committed to, again, the new T0 of 5:26 p.m. Eastern Time, liftoff of hopefully Goes You and Falcon Heavy from Launch Pad 39A here at Kennedy Space Center. You're seeing a great shot there from one of our cameras. But for now, let's send it back over to Daryl and Alec at the host desk.
All right, thank you very much. And earlier in the show, we asked you to submit your hashtag Ask NASA questions on social media. So now I want to take a moment to take some of those questions. Alec will be answering them. I'll be reading them. All right, first question up. Darren Priestley on X asks, what is the main driving force for the weather on Earth? Big question.
Yeah, it's the sun.
Sun.
The sun causes all of our weather, climate, sunlight, and the tilt of the Earth is dependent on the seasons. It's all starts with the sun.
And I imagine water on Earth plays a role. But if you're talking about the main driving force, it's the sun.
Oh, sure. Yeah, globally it's the sun.
All right. Very good. And we have another question. Next up, we've got Robin Kim on Instagram, and she asks, how is it different, Goes You that is, from other GOES satellites?
Yeah, Goes You is the same as the other in the series, except for the addition of the C-Core. And we're excited about this C-Core instrument, the compact coronagraph. It's a historic first for NOAA. It's the first operational coronagraph, and yeah, that's our new instrument, and we're really looking forward to seeing it in action.
How many of this particular series have been launched? We mentioned this is the 4th, so there have been 4, right? And this goes back to 2016 when this particular technology came out?
This series, yeah, that's right. Once GOES in space, it'll be renamed. Once it's in geostationary orbit, it'll be renamed GOES 19.
Right, very good. And then what happens to the existing satellite that was GOES East?
Yeah, currently we have GOES 16 in the GOES East position, and once GOES U finishes checkout and is ready for replacement later next spring, we'll move GOES 16 into orbital storage, and it'll be a backup, a hot backup, in case there's any problems with either GOES West or GOES East.
It's always good to have a backup.
Yeah.
And how are you doing on bingo, by the way?
I don't know. Where are we at?
I already scored. I think I'm winning. One more question for social media. Let's hit it. This is the last one. INS on Instagram asks, why won't Europe be monitored by the satellite?
Stage 1, BY and NY launch load has started.
And those are the boosters loading LOX into the first stage boosters.
Oh, let's go.
Yeah, we're moving. It's happening.
Yeah, this is a geostationary satellite, and so with GOES East and GOES West, we have complete coverage of the Western Hemisphere. It's a crucial piece of the geo ring. We have international partnerships, and so international partners have their own geostationary satellites, and they monitor other parts of the globe.
All right, thank you, Alec. And it's not too late to send in more questions. Just remember, you can go to #AskNASA on NASA's YouTube, Facebook, X, and Twitch platforms. All right, every rocket that launches from the Space Coast has a dedicated launch weather officer. And boy, that LWO, as they're called for short, is working hard today. That person is responsible for making the probability for go. So let's check in now with Philip Hargrove, who is with the 45th Weather Squadron's LWO, Melody Levin.
Thanks, Daryl. Yes, I'm here with Melody Levin from the 45th Weather Squadron at Cape Canaveral. Thanks for being with me.
My pleasure.
Awesome. So you have an extensive background in meteorology. Can you tell us what makes launch weather forecasting so unique?
Absolutely. So before I was a launch weather officer with the 45th, I actually was a meteorologist with the National Weather Service. So that's kind of a general field where your job is to protect life and property, and your main goal is to really get the forecast right and to basically predict the best you can just severe weather risks and general chance of rain, temperatures, et cetera, but protection of life and property is your goal there. With being a launch weather officer, it's much more different. It's very focused exactly on the pad, how things are going to play out from the pad and 10 miles out from the pad. The other thing is I'm looking for threats that would never really affect the average person. So we all know that we can't launch into thunderstorms or any existing lightning, but what I'm looking for on launch day is the risk of triggered lightning from the rocket, because we're essentially sending the rocket, we're sending a charged rod into the sky. We've done half the work for the atmosphere already to produce that lightning. So we're looking for threats that generally would not be a threat to the average person on the ground. We're looking at possible anvil, which we know we already went no-go at one point today for the detached anvil rule. So they're really kind of convoluted threats in situations where it's very unique to this field.
Right, it seems pretty complex. So how does that % go number get determined?
Well, that's the key question, isn't it? So really what we do is we first diagnose the weather pattern. So we look at the situation, kind of like today we knew we would have some light westerly flow. Normally when we have westerly flow, that's bad news for us in the afternoon, which, of course, that's when we're launching today, 5 p.m. to 7 p.m. roughly. So that's why we started with a high probability of violation. We generally, know that we're going to be above 50% because from a climatological perspective, we're likely to have thunderstorms during that time frame. And then we delve closer and we look at the finite differences today versus a general day in weather. So today we had much higher moisture than we normally do. So initially it seemed like our POV was up to 70%, but now we know locally we have a sea breeze boundary pushing inland that's helping us a little bit. So now our POV has dropped a little bit.
Awesome. Thank you so much, and excited to see this GOES satellite launch. Thank you, Melody. Back to you, Daryl.
All right, thank you very much, Philip and Melody. She's an LWO, as we mentioned. The LWO for the mission today is Brian Sizik, and he's been earning his paycheck today, helping SpaceX navigate the launch window. Of course, we slipped 10 minutes.